Thank you and good morning. It's my pleasure to be here. Obviously, we've lost some of our colleagues in the audience, so a little bit of a graveyard shift. But the aim of this talk is really to describe an approach that is enabled in the era of the software-defined data center. And specifically, that's how we can leverage the capabilities and the functionality that we have within the overlay networks that we create through network virtualization. And we're going to talk about that approach in a generic set of contexts. So it's not an NSX pitch, but instead, rather, it's just talking about some of the concepts that can apply to network virtualization. Of course, I'm happy to talk about NSX after this event. So if we think about what do we see in the current data centers of either service providers or enterprises today, and typically what we see is a zone-based security model. You have a trust zone, you have an untrust zone, you have DMZs, etc. But we still see today many high-profile security breaches in our industry. And those can be the reason for very lax security governance and policy. Examples might be storing all of your passwords in a plain text file. But it can also be to spear phishing, maybe to develop a targeted advanced persistent threat. And there what we see is exploits whereby somebody takes over or takes control of a vulnerable host. It could be virtualized or physical. And then they use that as a platform to then laterally attack the rest of the data center. And we have seen this over and over again. And when we boil it down and look at the reasons why somebody is able to do that, it's typically because the zone-based model is not suited to the modern data center architectures whereby most of the traffic is now east to west. And we now need to get to a finer grains control over the traffic that traverses our data center. So as we look at the approaches that we can take, then what we're going to do today is look at how can we evolve the zone-based model that we have today, which is mandated typically by topology, and move that to something that we call microsegmentation, and then how we can evolve that to actually address the security threats within the data center. So we think about the possibilities, the inflection points that we have to apply policy enforcement within the data center. Well, if you think about a virtual machine is a logical container for the application and for the operating system instance. Now, for many years, one approach we have taken to security is to actually install the policy enforcement engine actually inside the guest operating system. Now, the issue with that is the fact that actually, as soon as you put it inside the guest, it then can actually be subject to the target of the exploit or the attack itself. But the reason why we've done this, why we've been forced to put this policy enforcement point within the guest, is because it provides the maximum level of context. So if you think about what you can actually do within the guest, you can guarantee that an Ethernet frame or a packet that comes out that specific socket from that OS, you can guarantee that it came from that OS because you manage that, you own it. You can also look at the application, you know which application it came from. There is a huge amount of context we can associate with that information. But the problem is that how do you overcome this problem about the fact that you are now in the bullseye of the target? Well, you could actually try and do it in the physical network. That could be another approach. So the thing about being in the physical network is now you've removed that target that we had before in the guest OS. You've abstracted yourself from the guest OS. You can apply the security policy enforcement within the physical network infrastructure, and typically we see that today in physical network appliances. But the question comes, what kind of context do you now have? The reality is, if you're a physical device and you receive a packet from somewhere else in the data center, the best that you can hope to achieve is you can infer what that packet actually is. There is no way for you to absolutely be certain that that packet came from that socket on that guest OS, from another machine somewhere else in the data center. There's absolutely no way you can guarantee that. So from that perspective, you get the isolation, but of course you now have very little context about what it is. And of course, things like encryption completely negate the benefit you have within the guest OS, within the physical platform itself. So the question is there a better way? And what we're going to do explore in the context of this discussion really, and we'll continue to come back to this, is where can we actually apply security in a way that we get ubiquitous security policy enforcement. So we've been doing network virtualization now for many years, and you've heard some presentations this morning about how network virtualization can be achieved, how we can build overlay networks. And if we start from the most macro level, then of course we can provide native isolation today using overlay networks. We've seen this in many instances whereby we have test and dev environments. We can create overlapping MAC address domains, overlapping IP address domains even, so that we have complete isolation between those tenants, between those application stacks, whatever it might be. And in this example, this diagram tries to illustrate that with a blue and green network, which has overlapping IP addresses, etc. But native isolation is a pretty coarse way of providing security policy enforcement. It really just gives you that ability to partition your infrastructure. So again, is there a way to evolve this? And if we think about the security model, we come back to that zone-based model we see today within current data centers. Then really what we typically see is a set of physical perimeter gateways within that data center, and actually there's little or no control within that data center itself. Now, of course, you might have multiple appliances, multiple devices to build out your different zones. So, for example, you could have a pair of firewalls for your internet access, a pair of firewalls for your e-commerce access, a pair of firewalls for maybe internal connection. But the reality is that the zone sits behind those firewalls, and everything has to go through those firewalls in order for policy enforcement to be applied. Now, if we think about what's driven this model, is of course topology, and indeed this is what for many years we have an example of a three-tier application. In order to apply policy, of course, we have to route that traffic via the firewall. Now, there are different implementations and incarnations. We've seen people try to do transparent firewalls, etc. But from a conceptual perspective, really what we do is we use VLANs and networks, and we route between those VLANs in order to insert ourselves into the data plane and insert ourselves into the policy itself. Now, if we transition to a model whereby actually in the data center environment, we actually see a need and a desire to move to more flat-based architectures or flat-based topologies. Now here, for example, we have their web application and database tiers all on the same network. Why? Well, the reason is, as a developer, do I really have to worry about subnets? Do I really have to worry about network tiers? Why should I have to even care about this? Why can't I just have like a network and I just connect my workloads to that network and I'm done? I want to write my application so it can communicate. I really don't want it to be bothered by this network stuff. So this is one of the reasons why we actually see a lot of requests from our cloud management platforms to be able to support this flat architecture that we see on the topology here. But of course, the question is now, how do we apply security? I mean, there is no routing now between the tiers. It's a single flat network. It's a layer 2 broadcast domain. We can have connectivity between any virtual machine and any other virtual machine without any policy enforcement. So the answer is, well, maybe I could go and deploy firewalls in every single one of these ports. Now, if these are physical hosts, that may work, and we have seen some attempts to try and do that using access control lists. But the reality is today, to try and mitigate against the advanced persistent threats that we see, and when you look at the evolution of next generation firewalls, then really it's ill-suited to this model, this architecture. And of course, it then becomes operationally infeasible to apply. You end up with many, many firewalls. It becomes very complex, very challenging. And then somebody like VMware arrives in the scene and says, do you know what? We can virtualize all of this stuff. So what we're going to do is we're going to build a hypervisor. And as soon as you build a hypervisor and you put these workloads on a hypervisor, guess what? In this instance, everything remains within the hypervisor. You will never see the traffic on the physical network. So then how do you apply security? So again, it comes down to this challenge. How do we provide a ubiquitous enforcement, whether it be for virtual workloads or physical workloads? And how do we achieve, I guess, the model we have today with centralized policy definition, but have distributed policy enforcement in a way that's ubiquitous across the data center? So if we think, what are the options we have available to us? Well, if you take a virtual machine today, that virtual machine is provisioned using a cloud management platform. And as traffic leaves that virtual machine, as we generate the Ethernet frame out of that VM, it is handed down and passed to a virtual switch. When it gets passed through that virtual switch, we have the option to apply a data processing pipeline to those Ethernet frames. For example, this could include things like quality of service parameters. It could include things like port mirroring. It could include things like rate limiting, quality of service. But it could also be firewall and traffic steering policy as well. And as part of that processing, we have the ability now to influence what happens to that traffic as it leaves the VM at the most granular point you can enforce within the network. Now, if you think about what we've just defined here as a policy enforcement point, that we can control, but also the fact that there is no concept of cut-through switching on a virtual switch. We see the entire Ethernet frame. So we have control over that entire payload, and we can do whatever we like with that frame. So we think about what we call microsegmentation, which really is fine-grained isolation within the data center, and how that can manifest itself. And of course, this can apply not only with vSphere, but can also apply with other hypervisors too. But if we think about the policy enforcement, how it works, well, today we have a virtual machine, and if we use the zone-based model we had before, we have to hairpin that traffic or trombone it across the data center. We have to take the Ethernet frame or the packet, which is this blue dot, and then send it across the data center, send it across that physical infrastructure for it to be processed. Now, this gives you a number of challenges. How do you dimension these physical firewalls? How do you manage the policy and state, et cetera, that exist within those firewalls? Now, if we transform that model and we move the security policy now and the policy enforcement from the physical into the virtual domain, then as the VM is instantiated and as we apply policy within the virtual switch, we now have the ability to take that Ethernet frame and we can allow or drop that at the closest point to the VM without actually having to be within the guest itself. Now, there are a number of benefits of this. Remember these physical firewalls down here in the middle of this picture? Well, of course, they have to scale to dimension to cope with all of the policy and all of the possible traffic that goes through that firewall. If we apply policy within the virtual switch, if we apply policy within the hypervisor, we only need to care about the virtual machines that reside on that hypervisor. If we have one virtual machine, we only need to care about the connection state information. We only need to care about the policy for that one VM. If we have 10 VMs, we only have to care about those 10 VMs. We do not need to care about all of the other VMs in the data center. Think about what that has in terms of a benefit of distribution of the policy enforcement engine within the hypervisor itself. It means we have a linearly scalable horizontal architecture to support distributed firewall services, something that's never existed before. Now, one of the nice things is that because it's virtualization aware, one of the benefits of virtualization are the carrier operations that we can support. So we can have disaster avoidance with, for example, vMotion. So as we vMotion, for example, or live migrate a virtual machine, whichever terminology you wish to use, not only do we migrate the state of memory for the VM, but we can also migrate the state of the connections table too. So this means that you have continuous operation of that virtual machine irrespective of where it might reside within the data center. Now, there is another aspect about this model that might not be quite as obvious as shown in this diagram, but one of the things we can do is today, policy enforcement is typically based on IP address, source, destination, and then you have the port number and application type. That's typically the 5-tuple we base security policy on today. And that has not really evolved over the years that personally I've been involved in security. However, we know a lot of information about that virtual machine. We know its infrastructure name, which is completely decoupled from everything else that the end user sees. We know the UUID. We know, for example, what the operating system type is within that VM. Indeed, we can assign attributes to that VM that are completely removed from what you see with an IP address. For example, we can tag an attribute on that VM container to say, this VM is a web server, this VM is production, this VM belongs to this user if need be. So we can apply that attribute to the VM. Now, the nice thing is that you can actually now build policy based on those attributes. No longer do you have to write a rule that says IP address A can talk to IP address B on this application port number. You can write a policy that says, this production VM that happens to be a web server that is not infected by a virus is allowed to talk to the internet. You can write that policy. If you're running virtual desktops in an enterprise environment, you can write one rule that says VDI rules. Basically, say anything that begins with a name of VDI can never communicate with anything else that's called VDI. One single rule. I don't care what IP address it gets. I don't care how it was instantiated. As soon as that virtual machine is created and has that tag applied, suddenly we create policy. In a previous life, I used to actually be a firewall administrator. And I can assure you, people used to ask me all of the time through change control requests to go and apply a security policy, go and update the firewall policy. Maybe the people in this room have got it down to a T, but I can assure you, nobody came up 6 months later and said, you can now remove that rule because I'm finished with that application. It never happened once in the time that I was a firewall admin. So you had to then go through a manual rule-based cleanup. What I've just described to you is a policy model. I write the template based on the attributes I give with my VM, and I don't care what IP address it gets. So as I instantiate the virtual machine, as I create the virtual machine, it inherits policy from the template. But of course, when I'm done with that application and I delete that VM, the policy disappears. The template still exists, but the policy disappears. Think about it. You've just introduced full automation of security policy enforcement for those virtual machines. This is something that completely transforms the way that we now do policy management in the infrastructure layer. So as we move through the process, of course, we talked about isolation, so we can separate development, test, production. We could separate areas of the network. We then have microsegmentation, so we can do the fine-grained control over the virtual machines. But of course, as I mentioned earlier on, it's much more than just applying stateful firewall. It's about actually mitigating against the advanced persistent threat and looking at things like next-generation firewall insertion. So the whole concept about service chaining, service insertion now becomes relevant. So the idea is to be able to take a services engine and redirect our traffic and specific interesting flows to that services engine so that we can have them processed by the vendor ecosystem that has that core competency for that specific function. It could be somebody who's interested in processing SIP traffic. It could be somebody who's interested in processing financial transactions. They have a core competency maybe for a DPI engine that provides that functionality. So we have to somehow provide a rule or some form of traffic steering policy into the hypervisor in a way that we can then redirect that traffic. So this is where we come to advanced services insertion as the next step up. So you have your security administrator. He has his policy management engine. And the key thing is that we're now working, for example, there are ecosystem vendors, people like Tufin, for example, who can define policy that can then reside not only on the virtualized infrastructure, but also in the physical infrastructure too. So when you have physical assets or virtual assets, you can have a consistent policy across both domains. So you generate your policy, and you register that policy with the SDN controller. Now, the SDN controller should know how to do that interaction. There should be well-defined APIs to do that. And as you register that policy, the policy in effect gets distributed not only to the physical domain, but also as part of the processing and instantiation gets delivered to the SDN controller to then push down into the services engine within the hypervisor itself. And of course, this services engine is something that can be instantiated on demand in real time as you need those capabilities. And we can have many services engines, of course. So as we push this policy into the services engine, the next step in the process is actually to define the traffic steering policy to make sure that our traffic gets sent to that services engine. And that traffic steering policy, of course, can match on anything that gets presented through the hypervisor. And as we said, we can match on everything that we see within the Ethernet frame. So as we push that policy now into the hypervisor, we now have that ubiquitous traffic steering policy point within the data center. And here, irrespective of whether it's a physical workload that goes through the physical device, of course, the policy will still apply in the traditional sense. But if it's a virtualized workload, we can redirect that traffic to that services engine. So here now you can take advantage of the broad ecosystem of partners who have core competencies in developing these solutions, but also we can take advantage of the traffic steering policy we have within the hypervisor. So as we move into the service graph creation, the service chaining, we have the ability now to take traffic based on these attributes. We can make decision criteria to say redirect through these virtualized network functions. We can apply this policy in a way that allows us to do any arbitrary topology and apply any of those service engines to that traffic. But it's still not enough, because what happens when we go to IPv6 and somebody does encryption? What happens if you do SSL termination within the guest? How do you move forward? How do you move beyond what we've just described? And that last aspect is something that is unique to virtualization, and one of the reasons why in a software-defined data center, we have the ability to go beyond what we can do within just the networking space alone. So as I mentioned earlier, we talked about the logical container that is a VM. That logical container hosts the application and operating system instance. We can inspect that container itself through out-of-band mechanisms to do what we call introspection. And examples of that might be agentless antivirus scanning. Do you need to run an AV engine in every single guest OS? Or is it better to have a centralized point that does the scanning on behalf of all those VMs? There's actually a number of benefits to doing so, obviously reducing the load on the infrastructure itself, but obviously making it more simple to administrate and enforce because it's out of band. We also introduced the concept of things like virtual patching. When we talk to our carrier customers, one of the issues they have is that many of these virtualized network functions we see in the marketplace today are based on general purpose Linux operating systems or some other variant of a proprietary OS. And the problem is you're dependent on that vendor to patch that OS should an exploit occur, or a vulnerability rather occur. Now, the key thing here is that if you can do inline IPS rules that are out of band to that guest OS, you can actually patch against that vulnerability without actually having to touch the guest OS. And we see people like McAfee, Trend, Symantec using the out-of-band mechanisms to create this concept of virtual patching, where no longer do you actually have to touch the guest OS itself in order to patch it. And of course, it brings other capabilities against data loss prevention, file integrity checking, and of course, posture assessment, patch management. All of the capabilities one may expect, we can now begin to do those out of band. Now, there are a number of different mechanisms to do that. Yes, there are some proprietary techniques, but there are also simple techniques as well. I mean, we have seen examples whereby people do snapshots or clones of a virtual machine and then do offline scanning. We see people also use things like flow inspection and flow programming to set this up as well. But I think from a perspective of guest introspection, it provides that next level of enforcement, which is beyond just the techniques we have within the hypervisor itself from a networking perspective. Now, we talked earlier on about the fact that we have this concept of policy, and we can apply this policy based on attributes of the virtual machines. Well, we now have the ability to not only combine all of these facets, the isolation, the microsegmentation, the services insertion, and guest introspection, but we can take all of those and use them as part of the policy manifest. So here, for example, we can do an agentless antivirus scan of the guest using introspection. And of course, we can write a rule that says, should you detect a virus within that guest VM, then of course we can tag that VM using an attribute, and then we can write rules that basically say, if that virus is found, then apply a definition policy to that particular traffic. For example, you could only allow it to access the quarantine lands. But the nice thing about this is that at no point did we actually have to touch or modify the guest to actually achieve that particular attribute. So when it comes to the SDDC, or the era of the SDDC, or the software-defined data center, as we said, you can do things in the guest, which will give you high context, but very low isolation. You can do it in the physical network, which will give you very little context, but high levels of isolation. And I think what hopefully we'll try to emphasize in today's talk really is the fact that if you want a ubiquitous policy enforcement layer, then to get the best context, to get the best level of isolation, then the best place to apply that will be actually within the hypervisor. And using the techniques we have around isolation, microsegmentation, advanced services insertion, and of course, guest introspection. Combining them gives you something that is unique in terms of a security policy model and moves us away from that legacy zone-based model reference that we've seen in the data centers today. So if I was to say moving forward, what would I suggest? So as I said, this hasn't necessarily tried to be a product pitch. Obviously, NSX does have relevance here. But the thing I would say is that the software-defined data center does give us an ability now to combat and challenge the lateral advanced persistent threats we see today. I would suggest to you, if you are using a zone-based policy model, then the reality is I think that's outdated, and I think you might want to consider alternative approaches. We think that microsegmentation is key to enabling this, because microsegmentation gives you that fine-grained control and allows you to adapt and evolve to support any topology that you might have to support. But the point is that VMware alone, for example, cannot achieve this. It does require collaboration with the vendors in the security industry and in the networking industry. And this is going to require collaboration because core competencies around antivirus development, core competencies around IPS development, core competencies around patch management are all things that have significant value, and VMware has no ambition or strategy to go and attack that market. But what we want to do is provide the ability, obviously, to bring those vendors together and be the platform for the consumption of those services. And being a consistent and predictable platform is something that we're obviously working towards. But of course, we cannot stand still either. We have to evolve and adapt to both existing technologies, but also anticipate what's coming down the line as well. As we see containers begin to evolve, there has to be a way to adapt and support container technology and apply some of the techniques we've described today to apply to containers. We have to support IPv6. We have to support encryption within the guest. And of course, there are advanced security services we haven't even thought of today that we also have to be able to insert into this platform. So if I was to leave kind of one thought, I mean, the key point here is really to take advantage of the techniques we've described, But I do believe that the hypervisor and the overlay techniques that we have, and if you think about an overlay network, it consists of the hypervisor, the virtual switch, and the encapsulation. Take those components, use them as the foundational building block for the insertion of policy enforcement, still leverage the centralized policy definition, but I think it's the only way that we're going to be able to deliver both isolation and take advantage of context within the software-defined data center. So that was really kind of the flavor of the talk, but I'm happy to take any questions or any comments back from the audience. Please.
I'm brand new to this area, so I'm learning from your presentation.
Sorry, is there a microphone? Apologies. 1 minute, so, and I'll just have a...
So microphone's just coming.
Hi, I'm a novice in the security area, so I'm learning from your presentation. And so the concept of microsegmentation on your slide 10, it seems to me, if I understood what you're doing, is the point of control is on the hypervisor, but it seems to me the most microsegment would be the VM itself. And when containers come along, they would be the most micro segment. Can you comment?
Certainly. So if you think about the policy enforcement point, the Ethernet frame, for example, when it comes to networking, let's focus on that today. The Ethernet frame comes out the VM. As it goes through the emulated DMA and everything else from that VM and gets handed down into the virtual switch, at that point, we're actually applying the policy, so it's on a per virtual NIC basis, the granularity at which we apply our segmentation. That's why we call it microsegmentation, because it's on a per VNIC basis. And of course, the policy is then applied at that point. That is the only place where we have complete isolation from the guest itself. The guest cannot switch that policy enforcement off. But here's the thing, in a public cloud environment, for example, how can you enforce policy within the VM itself? Because you have no control over, for example, putting firewall policy into that guest VM. You cannot mandate that your customer runs a firewall in that VM. And how would you control the policy? So from that perspective, that becomes a very difficult problem to solve. And that's why we believe actually the best place for enforcement is actually when you take that Ethernet frame out of the VM, and before it gets switched or bridged or routed, you actually apply the policy at that point. So that's the reason why we've taken that approach. Hopefully that answers your question, but I don't know if there's further follow-up, or does that help at all? Okay. Please.
My name's Linda.
Linda.
I have a question. What you presented is really have distributed security policies and put them into the hypervisor. One hypervisor may have 20, 30 virtual machines, right? So how do you guarantee the policies are consistent? This is almost like a campus. You can have one door, one gate, which have all the rules there, so security staff, people can monitor the policies and make sure everything's correct. Or you can have many doors, and each door only control a set of people. So it's similar model, right? So I'm just curious, do you have a way to validate all the policies distributed, make sure they are consistent?
Yeah, it's a great point you bring up, actually. Maybe I should have covered that a little bit more detail in the presentation. So the key point from a security policy definition is that that should be centralized. It should be in a single place. You should have the ability to take that policy, define the templates, define the rules that effectively allow communication between whatever entity wants to communicate. At that point, then the system itself is responsible for maintaining the fact that that policy enforcement gets applied into the hypervisor, in our case, gets applied in a way then that is consistent with what you've defined as the policy definition. And there are ways to make sure that absolutely what you define in the hypervisor, for example, in the policy enforcement layer, matches what you've defined in the centralized policy definition. So those two are definitely tied together. But here's the thing is that it's actually applied to the virtual machine container itself. So if that virtual machine should move within the data center, the policy enforcement actually moves with the container. The old way of doing things was maybe hop by hop or instance by instance. In the cloud paradigm, in the software-defined data center model, the idea is to kind of decouple and abstract ourselves away from the infrastructure itself and move to an automated model. And this means you get away from configuration errors that are done because of inconsistencies. But rather, we move to a centralized, cloud-based architecture whereby we have a centralized policy definition model for everything within the data center. It's not just security, but it's things like quality of service, resource guarantees against noisy neighbor problems. It's around instantiating the entire virtual application itself, so you can actually have a virtual application container. All of those attributes are actually created in a cloud management system. Now, today, that could be OpenStack, or it could be a proprietary solution such as vCloud Director. But we have the ability to create all those in one place. But in terms of keeping consistency, the policy itself is where you, as a security, I guess, architect or an information security officer, defines the policy, and then the system itself makes sure it's consistent across the platform. Hopefully that answers your question. But
yes, so Jerome, I have a question. Do you see this technology being used mainly for data centers or for service providers? And especially the concern I might have is in service providers, I would see VMs, VNF, having generating a lot of traffic. Probably the ratio between compute and networking might be different in the case of VNF. So, do you see that for both deployments or mainly for data center?
I see actually for both deployments, and let me elaborate a little bit why. So there are two ways you can scale out a virtualized network function today, and that virtualized network function could actually be providing a security capability. So you can vertically scale that function, and there are a couple of ways you can do that. We could add more memory, which typically means more subscribers, more sessions, or you could add more virtual CPUs, which basically means you've got more performance, potentially more throughput. When it comes to an infrastructure platform such as what we've described today and a virtual switch platform, then of course then we begin to look at things like accelerated virtual switches, and we've actually publicly announced collaborations with people like Intel around their data plane development kit, both on OVS, which VMware is a significant contributor to in the community, but also within ESXi as well. So that gives you your vertical scaling model to help address the concerns about throughput and performance, particularly when it comes to, for example, a carrier. But there is also horizontal scale out as well. And there, of course, we use overlay networking to basically take the ability to have multiple virtual machines and have them basically horizontally scale out by adding more instances. And of course, the idea really behind what VMware announced with this vCloud for NFV platform with integrated OpenStack is able to do all of both the horizontal and the vertical scaling models, but also provide all of the resource guarantees in order to protect and ensure that you get the SLAs that are associated with those virtualized network functions. Because today, one of the challenges we see with NFVI is, in effect, it's very difficult to get those guarantees. And we believe actually that's the only route to do it today is actually using, unfortunately, a VMware platform. But we can obviously debate that separately. Hopefully that answers your question. But those are the ways we're trying to approach that problem. Also applies to the enterprise, of course.
Okay, just time for one more, I think.
Two short questions. Zdeněk, I heard that tool called Toffin. Is it already in plan, or is it already integrated with this technology? This is the first question, and it looks like say part of an NG firewall, but only with the server integration. Is there any idea or any vision to integrate it for the rules? I don't know, say customer or the employee A needs to communicate with server B. This kind of rules, which I would expect from the full-fledged NG firewall.
Okay, so let me take the first point. So Tufin is actually a third-party company. They have been around for many years, and their real kind of USP was the fact that they could define policy that could apply across multiple vendors' products. And we're really proud to say that they've also included NSX as part of that policy, or part of that vendor support. So that is shipping today. They have the ability to demonstrate that, and we can make an introduction if you require into Tufin to help explain the solution in a little bit more detail. But suffice to say, the benefit that they bring is that they can help define a ubiquitous policy that can then apply across your physical estate as well as the virtualized estate, and NSX becomes a policy enforcement point for the virtualized domain. Your second point about next generation firewalls is that today we partner with people like Palo Alto Networks, Checkpoint, and others to basically provide that functionality. And what we do is we instantiate a services engine, and that services engine is optimized for their solution. So they have different techniques and mechanisms, whether it be heuristics, whether it be signature-based, whether it be some other mechanism to go and actually apply that policy enforcement within the traffic that sees. And where the two work in tandem is the fact that the hypervisor itself, you program the hypervisors to say, I want to see these specific flows or these specific application types are redirected into that services engine. An example might be SQL traffic. You might redirect into a services engine to see whether or not you can mitigate against an SQL injection attack. That may be, for example, one use case that the services engine will apply to. So the idea is that if you've got host A talking to host B, you now have the opportunity to take advantage of stateful firewall functionality within the hypervisor using microsegmentation, but also the ability to do the advanced services insertion through the traffic steering policy that we have as well. So I hope that, again, answers your question, but if there's anything you want to follow up, I'm happy to say that as well. Well, look, thank you so much for your patience and your attention, and have a great conference and a safe trip home.
Thank you very much, Andy. Okay, our next speaker is Santosh Shasel from